Hello everyone, today I'm going to explain part B, similarity and dissimilarity in feedback. So we have briefly outlined how to compute dissimilarities between students' feedback profiles described by first a nominal attributes department, elective chosen, B asymmetric binary attributes, attended workshops, yes or no, C numeric attributes, that is CGPA attendance in percent, D 10 frequency vectors keywords in open text feedback. Dissimilarity is a measure of how different two data objects are. The method we use depends entirely on the type of data we are comparing. First, a nominal attribute, that is department elective. What it is: data that consists of labels or categories with no order, that is CSECE. MAC method is used is simple mismatching. How you compare the attributes for two students if they are the same, that is both are CS, the dissimilarity is 0. If they are different, that is CS versus ECE, the dissimilarity is 1. Overall, for a profile with 10 nominal attributes, the dissimilarity is the number of mismatches M divided by the total number of attributes P. D is equals to M by P. Now, asymmetric binary attribute, that is attended workshops, yes or no. What it is: binary, yes or no, 1 by 0, data where one value is much more rare or important than the other, that is yes is more important than no. Concept: a yes is match both attended is a strong similarity. A no match neither attended is a non-event and tell us nothing. We must ignore no matches. Method: Jaccard distance. Formula for Jaccard distance is equals to m1 plus m10 upon में m1 plus m10 plus m11. So m11 is the number of attributes where both students have yes, and m1 number of attributes where student A has no and student B has yes, and m10 number of attributes where student A has yes and student B has no. Note: we completely ignore m00, the no matches. Numeric attributes, that is CGPA attendance in percentile. What is it? Standard numbers where distance is meaningful. Method: normalize distance, that is Euclidean or Manhattan. Crucial step is normalization. You must normalize the data first. A 1 point difference in CGPA is huge, but a 1 point difference in attendance percentile, that is 80% versus 81%, that is tiny. So how? Normalize all numeric data, that is scale all values to a 0 to 1 range. Calculate distance using a standard formula like Euclidean on the normalized data. Now D is term frequency vectors, that is keywords in feedback. What is it? Text data where each student is presented by a long vector of a word count, that is student A, lab is equals to 5, faculty is equals to 2, food is equals to 0. Problem: these vectors are sparse, mostly zeros, and have different lengths. Euclidean distance work very poorly, so method cosine dissimilarity will work good in this. So how we measure the angle between the two vectors and not their distance? This checks if they are talking about the same topic. So we'll calculate the cosine similarity by the formula of A dot B upon me mod of A and mod of B. Calculate cosine dissimilarity by 1 minus cosine similarity. A dissimilarity of 0 means they are talking about the same thing. 1 means they are talking about completely different things. Now suppose two student faculty interaction profiles are represented as tuple 22:1, 42:10 and 20:0, 36:8, where attributes represent hours, spent in mentoring, project reviews, attended assignments submitted, infrastructure uses count, compute. Now first we have to compute Manhattan distance, supremum distance, Euclidean distance, and Minkowski distance with h is equals to 3. We are given two student profiles tuples and four attributes. Let's define them as P1 and P2. P1 and P2 में वैल्यू पुट करने के बाद द एट्रीब्यूट्स आर मेंटरिंग आवर्स, प्रोजेक्ट रिव्यूज, असाइनमेंट, इंफ्रास्ट्रक्चर यूज. By Euclidean distance, we put the values in the formula and calculate, and the answer will be D is average of 6.708. By Manhattan distance formula, N1 norm will calculate the pi I and pi q by D. So answer will be D is equals to 11. And Minkowski distance, we have h is equals to 3 and L3 norm. So answer will be 6.153. Supremum distance, L infinity norm, answer will be T is equals to 6. Now we have the media score is often a key holistic indicator of faculty or infrastructure performance when dealing with massive student feedback data sets. Purpose methods for median approximation analyze their complexity and suggest heuristic to balance accuracy and efficiency. The problem finding the exact median requires sorting the entire dataset for a massive dataset with n records that is billions. This is often impossible or too slow. Time complexity of O n log n and requires storing old data. So the goal is to find a very close approximation of the median, but do it much faster with less memory. Methods for median approximation is methods like Binning, random sampling, streaming algorithms, and we have how it works. So Binning histogram is grouping data into bins. Random sampling, take a small random sample of the data and sort this small sample and find its median. This sample median will be a good approximation of the true median. And we have streaming algorithm, which basically these are special algorithm designed for this. They make one pass over the data and maintain a small clever summary structure in memory. This summary can be called for any quantile like the median with a guaranteed error bound. So it will give us the accuracy and efficiency heuristics. Now consider student-faculty similarity analysis, a sample data set of two attributes: faculty, responsiveness, infrastructure support. We have student A1 and A2, S1, S2, S3, S4, S5 are the student data. Given a new feedback query S is equals to 1.4, 1.6. Rank existing student feedback profiles by similarity using Euclidean, Manhattan, supremum, and cosine similarities. Normalize each student's vector so unit length and recompute using Euclidean distance. So we have student faculty similarity analysis query vector x is equals to 1.4 and 1.6. Attribute faculty responsiveness 1.4 and attribute to infrastructure support 1.6. So we have a data of our student and we have to find the rank existing students की. So by putting the Euclidean distance L2, we'll find the rank existing for student, and by putting the Manhattan distance L1, we'll find the student's vector. Now we have supremum distance by L infinity, finding the max of S1 which is 0.1, S3 which is 0.2, S4 which is 0.2, S2. So basically S1, S3 and S4 are the in the max. So will ranking it by the values. Cosine similarities, S1 angle is most identical and S5 angle is very different. Part B, normalize Euclidean distance concept is to normalizing to unit length puts every point on the edge of a circle radius is equals to 1. This removes the magnitude, how big the number are, and focus purely on the ratio, the relationship between the attributes. Observation: when a vector are normalized to unit length, Euclidean distance produces the same ranking order as cosine similarities. New ranking will be S1 greater than S3 greater than S4 greater than S2 greater than S5. Note S3 moved up to second place because it has the same ratio of feedback as S1 even though the raw numbers were larger. So this is all for part 2.